All right. So, oh wait, there we go. All right. So let's start off with something else that could be, I guess, be a little bit more of a recap than a brand new concept too. Just go over some basics of simple loops, and also some basic debugging tips that could help you as you work on more and more complex projects. So for this one, we're going to go over the two most basic loops, which are going to be while loops and for loops. You should touch upon them a little bit already in JavaScript Jumpstart and also the Bootcamp Prep, but we'll just kind of reiterate some of the finer points there, talk about some of the keywords, and also do a really quick section on debugging. And debugging is one of those things that, like, I don't know, like when most people think a programmer who writes code is like, oh, you're writing code for like 80% of the time. It's like, no, you write code for like 20% of the time, and then things break, and then you're just trying to fix everything that's breaking for like the majority of the project time. And so debugging is something that, like, until you start writing code, this will take up almost the majority of like a project's time, is just trying to figure out what's breaking and trying to figure out all the edge cases. Um, okay. Oh, too far. Uh, there we go. Okay. So a while loop, once again, hopefully everyone has kind of seen a implementation of it at the very least. So the while loop uses something that's called the while keyword. And in JavaScript, these things are called reserved keywords, right? Which means there are certain words that in JavaScript mean a very, very specific thing, which, it's probably part of the ECMA standard of saying, hey, guess what? In JavaScript, you can't create a variable called while, right? Because while means something very, very explicit, or very, very explicit. Just like you can't create a variable that's, you can't say var for equals or for equals, right? Because like there are certain words that mean something very clear in JavaScript, and you can't really kind of override that. A while conditional loop is used. Oh, sorry, a while loop really is used when you want to run something, really until a certain condition is met. The difference between a while loop and a for loop obviously is with a for loop, usually you have a set number of times you want this to run. With while, you could also run it for a set number of times, but whiles also give you the option, or I guess the luxury, of potentially running it for an indefinite amount of times, right? So one example of an indefinite is like if I want to roll a die until I get a six, theoretically I could roll forever and never get a six, right? But practically speaking, I can't tell you I'll get in the first 10 rolls maybe, but I can just say keep rolling it, and at some point I should be able to kind of hit my stopping point. Um, so the three parts of a while loop: you have the while keyword, you have the conditional, and then you have the actual block of code. Notice how we didn't mention it, but obviously this curly brace. When we say block of code, what we really mean is this piece of code is surrounded by opening and a closing curly brace. When we talk about scope, we'll talk more about why the curly brace is very important syntax, and why it's really important to have those in the right places. But for now, let's just say that it's while, you have your conditional in parentheses, you have an opening curly brace, you have all the code you want to run in the while, and then you have a closing curly brace, and that will be the entirety of your while loop. The conditional expression is something that we'll talk about coercion in the next lecture. But really, a conditional expression is something that will eventually, it will, like, if you say, like, if, like, or not if, but like if you say like a 1 plus 2, that will give you 3, right? Or if you do, this string plus this string, it will give you a third string. But the difference between a conditional and anything else is once you're finished doing the operation that's in a conditional, JavaScript will then on your behalf say, okay, great. For a conditional, there can only be one of two possible values. It's either true or false. So now that I've done all the operations you want me to do, let me look at what I get back. And is this true or false? If it's true, then I'll execute whatever's inside this while block code. If it's false, then I'm done with the while loop. And really, that's kind of usually how you exit out of a while loop, right? Because while loops are designed in some ways to potentially run indefinitely until a certain condition is met. So really, when you create a while loop, always just be very cognizant of, hey, when do I want this to stop, and is there a clear path for this loop stopping? Nowadays, the computers are good enough that, like, if you have a while loop that runs indefinitely, usually the computer will probably cut you off after a few 100,000 cycles, and the computer is totally fine. In the old days, obviously, you didn't have as much luxury, but now you can kind of get away with it. But still, like, it's just good practice for you to always be aware whenever you start a loop, especially one that has the potential to run indefinitely. Make sure that you understand when the stopping point is. So, having broken down all those parts now, a while loop is just very simply, hey, while whatever's inside of here, this conditional, is going to be true, do this. You'll do this code, and then you'll come back and you'll check the conditional again. And the conditional is still true, do this again, and so on and so forth and so on and so forth until eventually, theoretically, hopefully, you get to a position in which this conditional is false, and then you say, okay, great, I'm done doing the thing, I'm finished. So looking at this code example, then here, there you go. So here on line 1, we're saying, hey, let's create a new variable. We'll call it count. It's equal to 3. And all we're saying is, hey, while this number is greater than or equal to 1, let's console log out the number. And then let's, on line 5 there, let's also take 1 away from the number, right? So if we were to run this loop, the first time we run it, count is 3, right? And we say, great, count is 3. And then we decrement it by 1. So then the next time we run this loop, I will say count is 2. And then we'll say count is 2. We'll decrement it by 1. And then count will still be 1, as 1 is equal to 1, right? 1 is greater than or equal to 1, so this conditional still holds true. So then when we run this loop again, it'll say count is 1, and then we decrement count one more time, and it'll be now what? It'll be 0, right? We go to 0 and say, great, let's run it again. Is 0 greater than or equal to 1? No, it's not. It's false, right? It values to a false, so then we're done with the while loop. And that's the very basics of a while loop. Does that make sense, everyone? Everyone's seen this before, right? I really just want to make sure like you all kind of have seen this before in practice. Okay. Similarly, something like this, if you have this function or this not function, you have this while loop here. This will, I mean, I guess it will technically run once, but the inside of this will never execute, right? Because when we try to run this loop, what we'll do, the first thing is say, okay, great, is this true? No, I move on, right? So technically, like line 1 executes, but line 2 never executes. We do the check to see if we should run it, and we get a no on the first try, so we're just done with it, like we're over it. And then similarly, this is probably a lot more dangerous. This will just run infinitely, right? Because guess what? This true is always going to be true. At no point in this code block do ever change what true is. And so this will run until, I guess we say here, until the computer runs out of memory, or some computer safeguards kind of deep in the computer say, hey, this looks like it's probably a mistake by a user. Let me just cut it off and and have them try again. So this is just very bad, and you almost never want that. Yeah, that's what it will look like. Cool. So if you remember our earlier example where we had to keep decrementing count by 1 after every time, right? This is an example where it's like, so really like when I guess from a more practical standpoint, when you look at a while loop, one of the things that you really should kind of draw your attention to as soon as possible, really trying to figure out, is the while loop moving my condition to false? Like, is it moving closer and closer to a case in which it's false, right? And so in this case, it's actually not. So when we start off, it's true. It's saying, great, this is a count, but we never change count. And so count never moves closer to being not greater than or equal to 1. And because of that, this is just like the previous example where we say while true. And then like, because count is never changing, and this is true the first time, it will also be true every other time in sequence. And so because of that, this will also run infinitely. So whenever you run a while loop, also make sure that, usually speaking, the body of your code is somehow moving the conditional closer and closer to a state in which it will eventually become false. Okay. Any questions on while loops? All right, great. Next one, something else that you will probably see a lot more commonly, to be quite honest, because while loops does have this, edge scenario where it could run indefinitely, and so there is some risk. For loops are definitely a lot more common, in the sense that they're safer to use, and they're probably a little bit more kind of handy to understand, I guess, in some ways. So like the while loop, it really has a very similar setup in that you have the for keyword, right? So for, also a reserved word. You cannot create a variable called for in JavaScript. It won't let you. We don't have a few more optional things, and I'll go into more detail. And then similar, we have our open curly brace, block of code that's going to execute closed curly brace. In the for loop is basically when you want to run something for a predetermined amount of times. Now, theoretically, it's not always predetermined, in the sense that you could replicate the behavior of an infinite loop with a for loop. But for the most part, usually with a for loop, you use it when you want to run something for a set number of times. And how the for loop works then is you have 3 components, right? the initialization, the condition, and the final expression. In this case, this actually operates very closely to a while loop, right? So in the initialization phase, what you're just saying is, hey, I usually want to create a counter of some sort. Usually we do var I or let I. I usually stands for index. That's more of a kind of common nomenclature, but you can use any variable you want. So like let Kylie's new iterator or whatever you want equals 0, right, or equals 1, or equals whatever it is. Here, you're just creating a new variable that's going to start your counter. Usually the condition compares that counter to something else, right? Saying, hey, as long as the counter is less than this, as long as the counter has not reached this value, as long as the counter has not blanked, keep running this function, right? And then lastly is, how do you want to change counter, right? Like, are we incrementing it by 1? Are we incrementing it by 2? Are we, adding values or moving values, whatever it is? But just like in a while loop, this final expression, this of how do I change counter, this should get us to a position in which eventually this condition becomes false, just like in the while loop, right? So with any loops, you want to know where you start and where you finish, and kind of how you're getting from the starting point to the finish point. So abstractly, it may be a little bit more confusing, but I think once we see the code, I think everyone is pretty straightforward. Everyone is pretty comfortable with it. Here on line 9 here, so in the first kind of section in that parentheses here, we're saying, hey, let's create a new variable called I, right? We're setting equal to 1. That's our counter. And then we're saying, run this as many times as we want until I is less than or equal to 3. And by the way, after we finish every loop, increment I by 1, right? So the first time we run this function, we're saying I is what?
1.
I is 1, right? We run I is 1, or rather, let me backtrack a little bit. We do this first, say I is 1, is I less than or equal to 3? Yes, let's run this function, right? We say I is 1, and then we say, great, we're done with that, increment I by 1. And now let's do this process all over again, right? So it's like, this only quote unquote runs once. Then we run this in a cycle until eventually this condition becomes false, right? So the first time we run this, because this part only happens once, we only create the index or the initializer once, hence why it's called a initializer. We create this once, and then once it's done, we just run this in sequence over and over again. So we say, is 1 less than or equal to 3? Yes, let's log it out. Let's add 1 to I. I is now 2. Is 2 less than or equal to 3? Yes, log it out. Let's add 1 to I. I is now 3. Is 3 less than or equal to 3? Yes, log it out. Add 1 to I. Is 4 less than or equal to 3? It's not. And we're done at that point. Yes.
Just to clarify.
Sorry, shoot. Xanthi, right? Okay.
Just to clarify the difference between while and for in that way is that in the while loop, if you want to change it to move towards a false, you have to do it inside the block, whereas here you do it in the middle of brackets.
Yeah, that's one way. Yeah, that's definitely one possibility here. Here for the for loop, it's almost like you're like working on the iterator outside of the code block, whereas right in the while loop that we were looking earlier, you were modifying it within the code block. One thing that you'll notice a lot of is that you can actually rewrite most while loops and for loops into each other. Like you can translate a while loop into a for loop and a for loop to a while loop. So there will be a ton of similarities between them. Once again, right, as with most programming stuff, these are just tools. Use the one that you're most comfortable with that does your job the best. But they're by no means like mutually exclusive tool that does something very different. You can rewrite them in each other pretty easily. Do you have a question, Dan, or?
Yeah. I may have missed this. Why is there a colon at the end of is?
This is just so when we print it out. This is, well, I guess there should be a colon here. You mean right here, right, on line 10?
Yeah, I would think that wouldn't be needed, so obviously I'm not getting it, but I'm just trying to understand what I'm
this is part of a string. This is just to make it easier for humans to read it. So
no, I know you're concatenating like the value and I is, but
Yep.
I would think you'd just be able to write I is without the colon. Like you just have the
the comma you mean?
no, the
colon. Oh,
right here?
Yeah.
I mean, well, this is part of a string, so we can remove this and nothing happens.
Yeah, but then I would expect to see it up there, no?
Yeah, so this is a typo, I guess, in terms of like what is not showing up. Yeah, but like usually for anything inside of a string, just it's almost like when you look at it, it's like ignore like the string parts of it, because it's like you can put anything you want in there and none of that runs as code.
No, I'm just so beginner at the moment. Like,
Yeah,
I just
no.
want to make sure I'm not overlooking anything.
Yeah, so this is definitely like a typo. We'll probably fix this
Fair enough.
in the code days. But yeah, so there should be a colon after this is here. saying 1 is, whatever, or I is with all these numbers. Cool. And then something else, once again, right, like, for loops, usually when we think of a for loop, we think of it going from small to big and it reaches a big condition, right? But that's obviously not, you don't need that, right? We can also go from big to small if you want to do something in reverse order. We can do every other thing if you want, really, right? So at the end of the day, with a for loop and a while loop, right, all we're trying to say is, hey, we want to start here, we want to get to here, and this is how I want to get there, right? It could be every other number, it could be every sequential number, it could be every number less than this, etc., etc. But when you're writing a loop, just always make sure you know when you're starting, you know when you're stopping, and you know how you're getting from your start to your stop. That's like the very, very core basics of all loops. So in this case, we're starting at 5, and we're just, notice how it's I minus minus. Typically you'll see plus plus, but in this case, we're just saying, hey, I is a really big number at the beginning. Let's initialize the 5, and then we'll do our kind of, conditional code block. I forgot what they called it, but basically increment or modify the index over and over again, right? So the first time we do this, I is 5. 5 is greater than 1. We'll do this. We'll take 1 away from I, and so on and so forth. We'll run this in sequence until eventually I will become 0, and we'll say 0 is not greater than or equal to 1. So then at that point, we stop the function, or we stop the loop, and we're done. Same idea. And then this just shows that, here we can increment by any number, right? So if we want to do every other thing, how do we do that? Not rhetorical question. If I have a list of things I want to go, let's say I have a number from 1 through 100, right? I only want the odd ones. How do I do that? How do I print out only the odd ones? Right, plus or equals 2, right? I just jump from every number I add 2 to it, right? So if I start at 1, I get a 3, then 5, then 7, etc., right? So this is something that, you'll see, sometimes people use it to kind of do some creative stuff. But yeah, this is fungible, this is fungible, this is fungible, this is fungible, but you need every single one of them there, right? You can customize it however you want, but their presence is required to run a proper loop.
Is it the most common application of a remainder operator, like trying to create a bifurcation of odd and even in a code?
Yeah. So the most common use of like the modulo function is to figure out if a number is even or odd. Usually,
Yeah.
There's other use cases for it too, but like
So
that's
you just do
the
like
most common.
you could do I don't want to say divide it, it's whatever by 2.
Yep.
And then put like an equal or not equal, and that can give you like an odd or even output.
Yeah, we'll talk a little more about that when we talk about in the next slide about coercion and truthiness, because
Right.
really what you're leveraging there is that when you do a remainder, when you divide by 2, you're either going to get a 0 or a 1 back,
Right.
and those are both booleans,
Yep.
and so you're actually trying to convert it to a different data type, and that's where like the efficiency comes in. But yeah. And then similarly, much like how we use a loop to go through numbers, anything that you can iterate through, we can use a loop for, right? So it could be things like a string or an array or a list of whatever it is. In this case, we have this string that has the first 7 letters of the alphabet, and all we're saying is, hey, my index is going to start at 0. I'm going to stop when we're less than the length of the string, and then I'm going to add 1 after every time. And so what I'm doing here is I'm saying is, hey, I'm starting at 0, right? I'm saying, hey, let's print out the current letter. So whatever is at index 0, right? So I start here, I equals 0. Is 0 less than 7? Yes. So then we go into code block. We say letters or current letter is equal to the letter A, and then we console log out A, and we add 1 to I. So on the second iteration of this, what's I now?
1, 1.
I is 1, right? Is 1 less than 7?
Yes.
Yes. So then we do this code loop again. Then we add another 1 to I. What's I now? I is 2. Is 2 less than 7? Yes. We do this code block. We add 1 to I. Once again, over and over and over again until we get to a final condition in which we say, hey, I is now 7. Is 7 less than 7? No. Okay, great. Then we're done. We stop at that point. So this is how this loop works, right? It's just like we do this one time, and then we just cycle through these pieces, these 3 parts over and over and over again until eventually this is going to give us false. If it doesn't, then it means we probably wrote a really bad loop somewhere. Okay, and I went through that a little bit fast, but are there any questions? Was everyone able to follow that pretty closely or pretty clearly? Sure. I mean, the last one here is just this idea that like we can access we can access like a particular letter or a particular character in a string by giving it the index.
Mhm.
And so if we just say, hey, as long as the number is less than however long the string is, every single index should correspond to a certain letter.
Is that formula converting it? Like you're starting out with numbers, and then it's using the number of string characters to create it back to a number.
Well, so at this point, I is always going to be a number, right? We never change time. I is always just a
Right.
number. And so, given that we start I equals 0, and I will be less than the length, so this is the length of this is 7, right?
Mhm.
So the only possible values are 0, 1, 2, 3, 4, 5, 6. Right? And so what this loop is taking advantage of is the fact that, hey, if I say, if letters is a string and I give it an index, if I give it a number, it will give me back the character at that index, right? So for letters at index 0, the character's A, index 1, the character's B, index 3, or sorry, index 2, the letter is C, index 3, the letter is
so
D,
because I equals 0,
so on and so forth.
Yeah,
Right.
It's plus plus, it's going to add from 0 on.
Exactly. So we never change I, but we just use I, and we change the number to access different parts of the string. Tahira?
Yeah,
Tatira, sorry.
The last current letter line, so like say
Yep.
line 5
Yep.
was on line 3.
Yep.
How would that change? Or would it?
It would change a lot. Your code would probably break on line 3 because at that point this I variable doesn't exist. The I variable is only created, exists, and used within lines 4 through 7. So if this line is on line 3, then Jawas will probably stop here and say, hey, I don't know what I is. And we'll talk about that error in the debugging slides, in 2 more slides. But yeah, you'll get an error for using a variable they haven't created yet.
And that'll fail when it gets to 7, right?
It will fail when it gets to 3. Well, like, sorry, if you move this to line 3, the code will stop running at line 3 because it'll say, hey, you're using this variable that doesn't exist.
The original code, like the original.
Oh, sorry, the original code, yes. The original code will stop once I gets to 7. Because 7 will violate the condition. It will run on 6. It will stop on 7. Cool. All right, so 2 last things. Continue and break. Continue is basically a way for you to say, hey, like I want this loop to keep running, but let's just skip this instance of it, right? So let's say you have let's talk about like you guys, right? Let's say we have a list of people who've kind of paid their tuition, if you will, right? And some people who haven't. If we iterate through this list, we can say, hey, for every person, send them an email saying, please pay your tuition, unless of course they've already paid, right? In which case we say, let's just skip them. But I don't want to end this process altogether. I want to go to the next person in this list, right? That's how continue does. It continue says, hey, let's end this instance of the loop, and let's move on to the next instance. So if we look at this code here, we have, once again, our for loop on line 2. It runs through line 8. And really all we're saying is, hey, on line 3 there we're saying, if this number is equal to 3, just stop it. Just stop right here. We're done. Move on to 4, or move on to the next number, or the next instance in this loop. So when I equals 1, lines 3 through, like we'll run line 3, it says, hey, is 1 equal to 3? No, it's not. Okay, so we'll skip lines 3, 4, and 5, right? And we'll just console log it out. We add 1 to I is now 2. Is 2 equal to 3 or not? No, it's not. So we'll skip lines 3 through 5. We'll console log out I is 2. We add 1 to I, now I is actually 3. We come here, it's like, is I equal to 3? Yeah, great, let's do line 4. Well, line 4 says continue, which means skip the rest of the code in this particular instance of the loop, and let's just go to the next thing. So then we add 1 to 3, we get 4. Is 4 equal to 3? No, it's not. And we console log out I is 4 again. Which is why here, when we show the output of it, we console log out every number except for 3, which we skipped, because that's what continue does. Continue says, skip whatever else you're going to do in this particular instance of the loop, and just move on to the next instance of the loop. Any questions? All good? All right. So yeah, the continue keyword works in both for loops and while loops too. So if you want to skip something in a particular instance of a for loop or a while loop, continue will do the trick for you. So this is just, so you guys have access to these slides. So I'm not going to belabor this point, but just this is kind of like just another example of showing you how the continue works in a while loop, and very much the same way as a for loop.
So continue is a similar like application to like return. Except return is a finite, like it's a finalized like command, whereas continue is telling you.
No. So continue is the almost in some ways in use cases the opposite of return.
Okay.
If you use a return, what it'll do is it will actually kill not only this instance loop but all subsequent iterations of the loop.
Yeah. I'm saying like where you would enter that keyword, continue or return, like that at the end of the code, you're either going to tell it to like return that value, like, but it'll only do it like once. Whereas continue is a functionality that will allow you to, once defined, you can move beyond just that one block of code. Like you continue to.
Return is a very specialized word in JavaScript because so the reason why I'm making it maybe a slightly bigger deal than what your question is intending is because return not only breaks you out of like the for loop or the while loop, it also breaks you out of the function that the loop is in. So it's an extremely powerful word that like you should only use when you want to kind of exit this entire operation. Right. Continue is used only for a loop. So it's like if you have other code after this in the function, the other code will still run. If you use a return, that other code won't run either. So return impacts not just things in the loop, but potentially things outside of the loop as well. Yeah. The next word is probably kind of what you're asking for, which is called break. And what the break says is basically say, hey, stop this iteration of the loop, and also stop all subsequent iterations of this loop. So if I say, so one example for how we will use break, right, is I want to say, like if I go through a string of characters, I want to say, give me the first vowel. Well, just go through each letter, and as soon as you find a vowel, stop, and stop searching for the rest of the letters too, right? Because I got what I needed. So break is kind of like the corollary to continue, except rather than just skipping that instance and continue on, it actually skips every subsequent instance as well. So you can think of break as almost like a way to exit this loop at that point. Okay, so what is this trying to do? Migrate equals A. Okay. I guess what this is, this is probably not the best example, but you start off with an A and then you keep adding pluses to it until you get to A++, at which point you stop. A bit arrogant, but in any case, that's the point of this code, right? Like, so we start with A, and then which is migrate, right? This while loop has true in it, so we pretty much know that this while loop will run nonstop, right? Except unless we have a break or a return inside here, right? Because otherwise, like this conditional is never going to become false, right? So the only way to stop this function now is with a break or with a return. In this case, we take migrate, we add a plus to it, and then we check the length of migrate. If it's equal to 3, then we break it. If it's not, then we do this loop over and over again until we get to migrate.length equals 3, which in this case is going to be A++. So once we get to A++, we say, okay, I've I've complimented myself enough. I can stop now, and I do break, and it will end this while loop entirely. What will happen if I use a continue here? Okay.
It'll still be an infinite loop though.
Right. So you guys are so Danny and Andrew are both correct. Like it will get to A++. It will say, okay, great, just skip this loop and let's go to the next one. The next one says, great, let's add another plus to it. So it will be an infinite loop to Andrew's point, and to Dan's point, yes, we'll just keep adding pluses to it nonstop, right? So in this case, continue is also the incorrect answer because what we really want to do is end this while loop entirely, not just skip to the next instance of it.
Would it be one string of like A++, or would it be A++, 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 A++?
It will be A+++++, like pluses indefinitely, right?
Yeah,
because
okay.
we never reset this back to A. So it would every time we change it, it would just be adding another plus to it.
But Brian said something like, that's a good point, like if it got to 3, would it be A++, blank space, plus, like with the 3?
Well, we never added blank space anywhere. So the answer would be no, right? Because we only add pluses to it. And so it's just like a matter of like how many plus. And in this case, the other thing that's also a little bit interesting about this example here is that notice how like we don't do anything. Like if it is equal to 3, we break out. But if we make this continue, like nothing happens after between lines 5 through 10 anyway. So it's like in this case, this only exists for us to exit this loop. it won't add or remove anything else from it. Yeah, right.
I just have a basic question for the logic for the while.
Mhm.
How does that work? So my grade is A. While that's true, then you add a plus.
Yep.
What does that mean? While that's true, while your grade is still A, that's a given, and you ask.
Yep. So how do I know if I want to run lines, let's say 5 through 9?
That's my question, I guess.
Remember the earlier slide of
Yeah.
this is a while word,
Right.
this is a conditional,
Yeah.
and the conditional is true, then we execute these
Okay.
lines of code. In this case, we're literally just
Okay,
hard
got it,
coding it
got
to
it.
be true.
Got it.
Like we're gonna always run this nonstop.
Okay, right, got it.
Alicia, do you have a question or? Okay, go. All right, and then once again, whatever works in for is gonna work in while. So in this case, in a for loop, we can equally break, right? So in this case, what we're doing is we're saying, hey, by the time I get to 7, stop. We don't need to print out any number after 7. So when we run this for loop, we're gonna get, or in this case, we're going from 10 and working our way down. We go 10, 9, 8, 7, and at 7, we stop. We break out the for loop and we're done. We don't look at 6, 5, 4, 3, 2, 1 anymore. Cool. Xanthi?
So obviously this is like a basic example, but why? When would you use break when you wouldn't just put it in the top middle thing where that tells you how the middle thing? So you
Here?
I let's say equals 7, and then that would make it stop. Why? When would you use the break rather than putting it up there?
Yeah. You use break when you don't know when you want to start breaking it. So like let's just say let's just say let's say I have a list of people and their grades, right? I want to stop once I find the first person with an A. I don't know how many people, like it could be no one could have an A, right? In which case I just do the whole class, or the first one has an A and I stop at that point. So break is more like when you don't know when you want to stop. But yes, if you know for sure I want to stop at the 5th thing, then you really should build that into the iterator instead. Great. Any other questions? All right then. Okay, so that was it for loops, while loops, for loops, breaks, continues. Hopefully, fairly fundamental stuff. Debugging is something that we're going to talk a little bit about, and really, we're going to talk a little about it, but you're going to do a lot of it when you write your code today. So debugging is, like I said earlier, it's where a lot of developers spend maybe the majority of their time, possibly. If you go to, so in the LearnOut platform, when you start your workshops, you actually now see a link to each individual question. And what we've actually done is we actually put them on CodePen for you. And I'll kind of show you the example later. But all of to say that now on CodePen, when you write your solution and you click run, we'll actually have a bunch of test cases for you that will run against these test cases to make sure your answer is gonna, meet the criteria that we need it to, right? And what we're talking about here is just some of the common errors that you will see. In this case, this is Jasmine. I think this is a test framework that Kojo was referring to earlier. Kind of like this is just another tool that we use for testing stuff. It makes life easier. You don't have to use it by any means. But the errors that it gives back are very typical errors that you would see in almost all JavaScript platforms. So we just want to make sure you understand what that means. So one common one that you'll see is reference error. And reference errors is very quite simply, hey, you're using something that you haven't created yet, right? So to Tier's example earlier, like she was trying to use this variable called I, but you don't create it until much later in the loop. And so at that point, JavaScript will say, hey, I don't know what I is, and I can't just guess what it is, right? So I'm just going to stop and say, you need to rewrite your code, and at least give me a variable at that point that I actually know what the value is. So whenever you see reference error, it means you either didn't create it, or in your case, more likely is you didn't create it at the right time or in the right spot. So so when you see that, and if you see yourself creating a variable, just make sure that if pretend you're a computer and run through your lines of code one by one and be like, okay, at this point, do I actually know what this is, or have I actually created this yet? And then just no, then you get this error. Yep.
Is it true functions or variables you can create them at the bottom, but it gets hoisted to the top or something?
Yeah. So hoisting is something we're talking about a little bit more when we talk about scopes. But this is typically more like. So the short answer is yes, you can hoist things, but for now at least, just do them in a way. Usually this happens is when either you're creating something inside of something else that doesn't have access to it, or you just don't create it, period. And so when I say like you're creating the wrong order, it's less like in the order we execute, but more like in the order in which like things get created. Kind of confusing. We'll talk more about it with scopes. But long story short, when you see this error, just make sure you're creating it in the right spot that you think a computer would recognize it. And usually when you look at most of these error logs, right, not only will it tell you what your error is, so in this case the reference error is, hey, you're trying to use something called sum, and you never created sum, right, so I can't use this thing. But not only that, it'll actually tell you the like what lines of code it ran to get to that particular break. This is a double-edged sword in the sense that like if you can follow it cleanly, it's really helpful. A lot of times there's a lot of junk here, right? So in this case, what this is saying, hey, when I download the page, I downloaded the Cloudflare like CDN or like external third-party library. This has absolutely nothing to do with us. But the computer doesn't know that. The computer's saying, hey, I did this, then I did this, then I did this, then I did this, and then I got this error, right? So I think part of your development as a developer really is to also make sure that like when you start reading these error logs, like make sure you understand like, okay, at this point, this is where it starts becoming relevant for me, right? Like for example, like it's like if someone asks you like, oh, who broke the vase? If I start my story with, well, I went to college, 10 years ago, and I did this. It's like, okay, that's great, but it's not relevant to this particular story, right? That's what this is. Is like the computer will only give you kind of very explicit things, but it's up to you to determine at what point it becomes relevant to you. So in this case, when we look at this code, this line is just not relevant because we're downloading a third-party library. This line, second from the bottom, it's a little bit more relevant because it has to do with this particular page. But really, this last line at only odds, we see that on line 11 here, on character 7, is when we try to use this thing that's not created. And so you'll get a better sense of how to read this as you do more and more of these problems. But just know that like usually like how the call stack works is like it will say what the error is. It will talk about the next line is going to be the last line that ran successfully to get to the error. Then the last line that ran successfully before that, on and on until you kind of get to the very beginning of the page. So you want to start from the top and work your way down, and at some point it will stop becoming relevant to you. Okay, so that's just for reference errors, but like this idea of going through the errors line by line, trying to figure out what the error is, this will work for almost all debugging. Don't tell me, I should know this. Leo? Yeah. So. Yep. Yep. Yeah. Yeah. Yeah, I mean, usually like the line number is enough. Characters is a bit superfluous in most cases, but yeah, usually the line number, and in this case, the error is clear enough that like, hey, you're. I mean, if I look at this without knowing anything about the code, I would say, well, in line 11, you're clearly trying to use this variable called sum somewhere, and that's kind of where you start thinking about the error, right? Because like this is gonna tell you, this is more useful for telling you where your error is and what the computer's trying to do with it, and less like how to fix it. Like how to fix it is kind of where you as a human really can kind of needs to leverage what you know. But this will at least tell you where the computer starts breaking. The reason why this is sometimes not foolproof in terms of determining when the error is because sometimes like sometimes the computer will actually like if I give a computer an invalid value, it will yell at me, right? If I give it the wrong value, if I say hey, like this is you should be expecting a number, and I give it a different number, the computer won't know that, right? It will keep using that wrong number over and over and over again until something else breaks. And they'll say, hey, David, this thing broke. But really the root cause happened like a while before that when I fed it a wrong input, maybe a while ago. And so once again, that's why you want to work back from the stack traces because where it broke is not necessarily where like the error is happening. It's just eventually that's what actually broke it. Yeah. Okay, cool. And then lastly is failing test. This is something that on CodePen, when you run the test, it'll say, hey, we're trying to pass these 4 tests, and one of them is failing. And if you look on that test, you'll see what it's trying to test for. And usually in the test, it'll actually also tell you why it's failing. So in this case, this is saying, hey, I expected to get back 55, and I only got back 20. Or sorry, I expected to get back 25, and I got back 55, right? And then at that point, you actually look in the test to see how it got to that position or how it ran the code so it expected to get 25, and then when it ran your code, how did it run your code to get the 55 number, right? So this is just more specific to Jasmine in the sense that this is saying I expect to get A, but I got B instead. And then it's up to you to figure out kind of like why they expected A and why your function gave back B. Right. This one, okay, yeah. So this one I'll show you guys in person how the CodePen code works. Okay. So the reason why I'm skipping over these slides is because these are something I'll just like show you in person. It'll be a lot more helpful than reading them off a slide. So let me just go to. Okay, so this is one of the first examples that you'll look at, and it's this. Okay, cool. All right, so this is like basically a code, right? And so when you go to this link, so this link is pre-written for you. Once you come here, oh, sorry, let's see people squinting a little bit. Once you come here, we would have already written these tests, right? Everything after describe is a test. It's saying I expect this to be this. I expect this to be this. I expect this to be this. Yeah. Even better than me zooming in is if you go to learn.platform and you go into the workshop. Let's see, it's called what is it called? Bootcamp prep, loops, and debugging.
The thing is, I think it's a video that we have to follow along with.
No, so if you go on the left-hand side, you go to the problem section. This is the first problem called only odds. So if you click on that link, it will take you to this code page link. Essentially, the idea is that like you write your code where it has in text, write your code here, and then you just run the page. Everything like your function is gonna be ran against those test cases, and it'll just tell you if those test cases are working correctly or not. And so you can, for now at least, you can think of your function as being correct when you pass all the test cases on that page. So we wrote the test for you just because you should expect this, you should expect this, you should expect this, and then you can just run it on the page directly. Any questions there? Okay, the last thing I'll talk about is some of the other slides that I skipped over has to do with something called the Chrome debugger. Not sure if you guys have used this before or not, but does anyone? So I'll use Chrome for now. Firefox I'm very similar, but like Chrome is the one that I use, or at least I'm more kind of personally comfortable with. But essentially, every Chrome browser, right? Like I said, every browser runs JavaScript, right? So in the same way that when I visit Facebook or when I visit ESPN or any other website, like it gives me back a bunch of JavaScript that my browser is running, right? Well, great. I have this piece of software that runs JavaScript. In most browsers, you can also just write your own JavaScript, right? So when you open up the console on developer tools, so you can just right click anywhere and just go to, let's say inspect. It'll open up this thing. This will tell you all of the elements are on the page. But really, if you go to this third option in Chrome here called console, this just gives you a blank piece of paper that you can use to write JavaScript, right? So if I write something, like function like, David takes in nothing, and then it just console.logs out, console.logs out hi. Like, can't see. Okay. Like now I've created this function on my page called David. So on the next line, if I write David and I try to run it, it'll print out hi, right? This is just like REPL. This is just like CodePen. It comes built in to every browser, every major browser right now, right? So the reason I'm showing you this is because now if I want to write a function called function David, but I use this line called a debugger. Let me just okay. What debugger does is debugger actually, when you try to run the code, it will actually stop the code at that point and then let you run the rest of it line by line by line in case something's breaking and you don't know why. Now you can kind of step through it in the way that a computer would. So now if I try to run David, what's going to happen is it'll take me to this screen. It'll say, hey, at this point, you put this thing called a debugger there. And here are all the things, right? It tells you what all the variables I currently have access to are, what those values are, and most importantly, this little button next to it, this lets me now go through the next line of code and run through this the way a computer would. So at some point, if I know my code's going to break, this will kind of give me a more accurate reading of where things break or where things start breaking. So it's a tool. You don't necessarily need it for this workshop. We just kind of wanted to point out to you so that at the very least, when someone says I'm using a debugger, you have some sense of what the purpose of it, right? It just kind of pauses the code at a certain point and then lets you step through it line by line. A debugger is useful, but really when you write code, especially kind of at your level, you really should be trying to understand how your code's running anyway. So don't necessarily rely on this to figure out how your code's running. Like you should mentally have a good model of how your code's running. And that's pretty much it. So these next workshops are going to be on CodePen. They should be on something that's fairly familiar to you all. Any questions?